Hello everyone, and thank you for signing up for this TÜV SÜD webinar on Wastewater ZDHC Readiness Audits. I'll be your moderator today, and I will go through some basic information before we kick off with the presentation. Some basic information to keep this session as smooth as possible. Firstly, we have participants calling in from various locations, hence you are automatically placed on mute to reduce background noise. Secondly, this is a 1-hour session which includes 15 minutes for question and answers. At any time during this session, you can send in your questions directly to the host TÜV SÜD, and we'll address these questions at the end. Lastly, this session will be recorded and made available on demand later. We will also be sending you an email with the download link to the presentation slide later this week. So before we start, I'll give you a quick introduction on the speakers today. So we have with us Dr. Richard Woodling, who is the Senior Head of Water Services at TÜV SÜD. Dr. Woodling has a deep background in water technology and a wealth of experience throughout the water industry, including industrial wastewater and recycling, advanced biological treatment, and low-energy desalination. Dr. Woodling sits on 5 ZDHC task teams associated with the output. He earned his PhD from the University of California, Riverside, and has since published more than 70 papers on water technology topics. In addition, we also have Dr. Subhagya Patanayak, who is the Senior Program Manager at TÜV SÜD. Dr. Patanayak has more than 12 years of technical advisory and R&D experience in water and wastewater engineering. He has know-how in membrane technology, biological treatment, modeling and simulation, and physiochemical treatment. In that time, he has consulted Fortune 500 companies and has contributed extensively to the scientific literature through book chapters, journal papers, and international conferences. He attended the University of British Columbia, Canada for his PhD in environmental engineering, and he is a certified project management professional. With that, I will now hand over the presentation to Dr. Woodling, who will kick off with the introduction on ZDHC Roadmap for wastewater. Over to you.
Good morning, good afternoon, and good evening. Thank you for joining our webinar. Sorry, I'm waiting for this. Okay. I wanted to give you first a brief introduction of what Water Services at TÜV SÜD does. We are a consulting group, which is unusual for TÜV SÜD since it's mostly a testing and certification inspection type of company. We conduct audits, and our audits aren't just simply do you meet standards or not, but we'll go in and we'll examine how systems are performing, and we actually come back with a report advising the owners of the equipment how to operate it better. Along with that, in a very similar way, we do operational consulting. Operational consulting, we go in, we do a really deep dive into the operations of the system. We come up with recommendations for the operators in order to improve the operations of treatment systems. And this is not just for wastewater, but also purified or processed water. We conduct masterclass trainings in wastewater treatment, trainings in desalination. We also function as owner engineers. So the first 3 topics I discussed were associated with existing systems. As an owner engineer, for those who don't know, you work with the owner, and when they're getting a new system, you make sure that it's designed for function and that it'll perform. So we do many of the engineering aspects with the owners in mind, and ensuring that the system that is installed and started up will meet their needs. We additionally do work in the sanitation and testing area. Next slide. I'm going to give a brief discussion on the roadmap for wastewater treatment in ZDHC. It's a single unified program and deals with all discharges coming out of a textile facility. While today we're talking about wastewater, the ZDHC guidelines also include sludge, and in the future they'll include air emissions. It goes well beyond regulatory compliance, so that means it goes beyond the local and national government requirements of the country it's in. And it includes both the conventional type of wastewater parameters, so that means the typical ones that you would see, for example, in a municipal plant, and also it includes hazardous chemicals. It's applicable to the industrial and the municipal or domestic wastewater. Now, that's important as many of the suppliers to the name brands, they'll take both their domestic wastewater from the factory and the industrial wastewater, and they blend them together and they send them through the same treatment process. In the ZDHC guidelines, there are 3 levels that can be achieved by the facility. The first is foundational, and foundational, you at a minimum, you meet the legal discharge of your country that you're located in, the region you're located in, and that you ensure that none of the chemicals in the MRSL are in the wastewater system. So you meet some of the biological, conventional treatment systems, you meet the local systems, and you meet the MRSL. In that progressive level, you're demonstrating increasing knowledge of chemical management and advanced wastewater treatment processes. And finally, aspirational, and that's a best-in-class performance and improvement in both chemical and wastewater treatment. Typically, from a wastewater perspective, the foundational, progressive, and aspirational has to do with the concentration of chemicals in your wastewater after treatment as you're discharging it. So the more, the higher rating in the guideline is aspirational, and it is the best. You have the lowest concentrations, or you're below a much more stringent requirement than foundational. Next. The wastewater and sludge part of the roadmap explains how to do sampling, and is conducted using an ISO format 5667 standard, composite sampling requirements. The sludge produced from zero liquid discharge is properly classified, and as I mentioned a moment ago, that'll be getting defined even better this year. Handling of sludge by a third-party waste hauler should be clearly understood. There's also minimum reporting frequencies and for conventional and ZDHC parameters. This happens semi-annually with a report and testing completed by the 30th of April and the 31st of October. Those reports, after the suppliers give permission, the test reports are from the ZDHC approved labs or accepted labs. They're put up onto a website, a platform that the brands can turn around and review their suppliers and how they're performing. Next slide, please. The next section is preliminary assessment of the wastewater treatment plant, and I'll let Dr. Patniak discuss that.
Thank you, Dr. Woodling. So after the introduction of ZDHC Roadmap, the next slides we're going to discuss how we go to a textile wastewater treatment plant or textile facility and do evaluation of the wastewater treatment plant. So, first thing we do is we look into wastewater, influent wastewater. This is because textile wastewater contains a lot of dyes and chemical additives. And as far as pollutants are concerned, there are suspended solids, color, organics. Wastewater has a high pH or low pH, and it contains also heavy metals and other soluble hazardous substances. So what it means is that the wastewater has many pollutants. The second thing is the wastewater characteristics also varies quite a bit. So if you look at the table we have displayed, look at the BOD, COD, and total suspended data. It's quite, it goes from very low value to very high value. And this happens if you go from one facility to another facility. But it also can happen within a facility, depending on the production and depending on the day of a week, a production week. So for us, when we go to a textile facility and we're looking into wastewater treatment plant performance, we look into wastewater characteristics in a very in-depth manner. The second step is understanding the wastewater treatment plant. So both the wastewater characteristics as well as wastewater treatment plant information, this preliminary assessment takes place it's kind of a desktop analysis we do. So we ask our clients or the facility owners and operators to send us this information, and then we look into them in a detailed manner. So as far as design and O&M operation and maintenance of a wastewater treatment plant is concerned, we focus a lot on the effluent discharge requirements, the efficiency of the wastewater treatment plant as far as removing specific contaminant or a number of contaminants, and then the flexibility, complexity, reliability, robustness of the process. Then sludge, chemical, energy, as you know, they're very important in any wastewater treatment plant. We look into operation and maintenance practices as well as costs associated with it. And then we also look into the capacity of the existing capacity of the textile facility as well as the future expansion plans. As far as the process is concerned, we focus on wastewater, that is stream segregation, whether the wastewater has biodegradable component or non-biodegradable component, what kind of dyes are present, difficult dyes that are difficult to remove, and then temperature. A lot of the times temperature can be very high in textile wastewater, so we look into the variations. Then presence of oil and grease as well as heavy metals. Then also suitability for recycling. And all this, including performance data, we get from the facilities, and then we prepare ourselves for the next step. So that is when we conduct site audit. So site audits, depending on the size of the facility or size of wastewater treatment plant, how complex it is, it can be a single-day site audit or multiple-day site audit. The idea here is we compare the drawings because the plant can be a couple of years old, and with the current operation strategy. So just make sure that everything is in place, what is in the drawing. And then we took a tour of the plant so that we see firsthand what is happening. And then finally we have a meeting with the plant operators, owners, and other stakeholders, and understand what have been the issues in the past or what are the existing issues. So once this happens, when we are on site, and we have done, we've gone through the data that has been provided to us, and we see that, okay, the data is not sufficient, we recommend sampling for around 7 days. Why 7 days? Because we want to make sure that we are capturing variation in daily production for a week. And the sampling we do for influent, some critical processes, and effluent, and then so that we have a very good clarity regarding the health of wastewater treatment plant. And the parameters we have listed here, they are CODs, organics, nitrogen, phosphorus, sulfur, sulfide, alkalinity, suspended solids, calcium, magnesium. So here we have to, I should make a clarification. When we recommend sampling, a facility does not have to go to a ZDHC approved lab. They can do it either in a local lab or if the facility has an internal lab, that is also sufficient. For us, the objective is to know what is happening across the wastewater treatment plant. But of course, if there is ZDHC conventional MRSL data is available from third party, and if it is made available to us, it is quite helpful. So once we have done completed site audit, we go to the details and we try to understand what is happening to the core wastewater treatment plant processes. So in most of the textile plants, you have a combination of physical chemical treatment, biological treatment, and advanced treatment. And we are going to mention the key processes that we come across in the textile facilities when we go for audits. But not, I need to mention here that not all of these processes are there in each facility. So depending on the wastewater quality, depending on the regulation requirements, some of these processes are there and some of them are not there. So I'll first talk about the physical chemical treatment. Very important is equalization and homogenization, because you have a lot of quality and quantity fluctuation happening, and then also you have complex contaminants present in the wastewater. So equalization, homogenization takes care of it. Flotation is important because if you have oil, fibers or oil and bleach, then flotation systems like DAF, they can take care of, they can remove these effectively. And coagulation, flocculation, sedimentation, or we call it, it's a chemical treatment unit, we typically call it, are there for removing suspended matter and colloidal matters. So biological treatment, the objective is basically BOD, COD, color, nitrogen, phosphorus, others. These are the things that are removed through biological treatment. And in textile facilities, we typically see aerobic biological treatment, where oxygen is needed by the bacteria to remove the pollutants. Activated sludge process is the predominant application we have seen. So there can be conventional clarifier based or MBRs. We see more and more MBR nowadays. And or attached biofilm processes, for example, mixed biofilm bioreactors, MBBS, also we see them. And then anaerobic biological treatment, where the principle is bacteria operate without oxygen, and they are very useful when you have very high concentration organic wastewater, or if you want to remove, if the facility has azo dyes. Advanced treatment is applicable because it's seen in textile wastewater treatment plants. Not every textile wastewater treatment plant, but selected ones where the recalcitrant organic or the ones that cannot be biodegradable, they're found in textile wastewater. So the conventional ones like treatment systems cannot remove them very well or efficiently. So membrane technology and advanced oxidation process is very commonly used. Two types of advanced oxidation process we come across quite frequently: Fenton process and ozonation, and both of them remove organics, as I mentioned before, that are recalcitrant, or the organics that are toxic to microorganisms. So what we do is, when we go to a textile facility and we look into the core wastewater treatment plant, the process, we look into the design first, and then we look into the operational principles. So for example, if somebody is operating a biological treatment process, we are looking at retention times of the tanks, the solids retention time as well. If we are looking into the Fenton process, we are looking into the retention time or the interaction between the chemical and the water, and the dosing rates of hydrogen peroxide. So these are the things we deep dive into these specific parameters or operation principles, and if we find an optimization potential, we provide recommendations, or if there are issues, then we try to give corrective recommendations. So the next topic is interesting, and we believe it is quite unique for textile facilities, that is using modeling in the wastewater audits. So for the modeling, we use a commercial simulation tool, that is Pathway, and that is from Enviris in Canada. It is quite well recognized for biological wastewater treatment, and it can. So Pathway can predict the fate of complex industrial organics, and also can be used to see if how a toxic compound impacts biological wastewater treatment process or the microbes. Pathway has been used in many industries and utilities globally. Has very high potential in textile wastewater treatment because the heart of most of the textile wastewater treatment plant is biological process. So I've spent some time explaining between what is the purpose. So the first is process design. So it does not matter whether you have a new plant or an existing plant. You can always evaluate the unit sizes and the operating ranges, whether they make sense or they can be improved, or the process is under design. And the second one is, if you are already operating a process, second and third one, if you are already operating a process, you are okay, you are satisfied, but you are wondering whether I can optimize it, then it can be used as well. Or if you have a problem and you don't know what is happening, then you can always use Pathway to find out the what if questions. And it is a fantastic tool for operator training, because it covers all the fundamental principles of biological treatment. So the benefit of this is, for facilities, is that rather than under-designing a system or over-designing a system for a new plant, you have a deterministic way of building a new system. And for existing wastewater treatment plants, you can always optimize your design, or you can always optimize your operation. Pathway can be used for conventional or clarifier-based systems, MBR, MBBR, and as well as anaerobic treatment systems. And we have used Pathway in a number of facilities quite successfully. And we have. I'm going to talk 3 case examples, and where we have used Pathway and the processes are different from each other. So the first one is the wastewater treatment plant is in China. The wastewater treatment plant is extended aeration followed by NDR. The plant has been meeting the national discharge guidelines consistently. It requires external addition or dosing of nutrients, nitrogen, phosphorus for a viable biological system. And the effluent from the wastewater treatment plant is used for recycling. So Petwin was used to understand whether the process or the whole wastewater treatment plant as well as the unit processes, that is includes equalization tanks, bioreactors, aeration, addition of glucose, all these things ensure that the wastewater treatment plant is meeting ZDHC's foundational, progressive and aspirational targets. And the second one was, as I mentioned just a couple of minutes back, that whether the addition of nitrogen phosphorus is sufficient. So if they're adding less than required, then the viability of the system is in question, then it's a problem. If they're adding more than required, then there is a nitrogen and the phosphorus in the effluent. That means there is a violation as well. So Petwin helped in these two. Petwin helped the facility to understand where they stand as far as GDHC requirements are concerned. The next one was is in Indonesia. Again, it's an extended aeration system. Quite a number of aerobic tanks, followed by clarifiers. The wastewater treatment plant was a physiochemical one. They shifted to biological process recently. It is not performing as expected, and they're not meeting the regulatory requirements. So the facility owner wanted to have a comprehensive understanding of where it stands as far as GDHC targets are concerned or guidelines are concerned, all three of them. Then GDHC has a target for nitrogen. The facility has high volume or high concentration of nitrogen, but the facility does not have any anoxic system to remove nitrogen. And so Petwin was used to see whether there can be modification that can be done and achieve both organic and nitrogen removal targets. And as in case example one, it was also investigated whether external nitrogen phosphorus addition is required. This is because the understanding was, if you look at we have not shared here, but if when we looked at the wastewater characteristics, there is sufficient amount of nitrogen phosphorus, but still the facility was adding nitrogen phosphorus to the bioreactors. And through Petwin modeling, we recommended that it is not necessary. So then that means there is a lot of savings as far as OPEX is concerned for the facility. So the third one is in Thailand. They're using an aeration pond, and they're meeting the discharge guidelines. But the problem is the wastewater treatment plant is taking a lot of space, and the facility has plans to expand production. Also, the facility has not been using sludge recycle. So that means what is happening is their biomass is quite low. So they're doing some kind of recycling around 20%, but their plan is to improve recycling improve recycling to a higher rate. So as in the case example 1 and 2, the facility was evaluated for readiness of ZDHC guidelines, which they met. But at the same time, there was an interest from the owners to see whether a more compact system can be used to replace the oxidation point. And we did use between and to see feasibility of a new MBR system, which was our modeling showed that it is possible and it can meet or even achieve better performance than what they're getting from this high footprint, a big footprint system. And also, as I mentioned, that they're looking into having a more modern water recycling system, a bigger water recycling system. The Petwin modeling data was used for the effluent of MBR to look into how a future water recycling plant would look for this facility. So the conclusion from all the three case examples is, apart from using our own expertise in different technologies that is used in wastewater treatment plants for textile wastewater, a tool like Petwin can also validate or confirm our assumptions, our thinking, and that benefits, that kind of deterministic tool benefits the facility a lot in the long term, especially considering they have to meet ZDHC aspirational targets in near future. Okay, so the next section is on water recycling opportunities. So as many of you may know, that water recycling is becoming more and more prominent in textile facilities. Why? Because it helps the facilities to meet their sustainability goals. So, for example, we went to a facility and they've reduced their water usage from hundreds of liters to now tens of liters per kg of material produced. So that's a significant improvement. Another benefit of water recycling is feed water to the production process is quite consistent. However, it should be mentioned that recycling from a textile facility is strongly linked to wastewater effluent quality. As in many water recycling facilities, reverse osmosis is the preferred choice. However, because of the constituents in wastewater effluent in textile facilities, the recovery percentage is a limiting factor, because you have to understand that facilities have to deal with concentrate, and concentrate management in textile facilities is not an easy task. To protect the reverse osmosis process, facilities usually have a membrane bioreactor for wastewater treatment plant, or if they have a conventional wastewater treatment plant, then they use microfiltration or ultrafiltration as a pre-treatment for the RO system to protect the RO. What we do during the audits, even though our focus is on the health of wastewater treatment plant as well as meeting the ZDHC requirements or guidelines, we see that how we can optimize or how we can fix the wastewater treatment plant so that they can achieve the highest quality effluent. And also, we look into, based on that, we look into feasibility, that is from a total expenditure point of view, for water recycling. So the next slide is training for operators. We have talked a lot about what is happening in textile industry and ZDHC. So we all agree that textile industry is going through fundamental changes, and everyone understands it, and that's why ZDHC is taking the lead and making sure that all the operators are getting trained. And for the operators, the objective of the training should be that they learn the new technologies, and they're operating their systems more efficiently, and so that they're meeting the stringent requirements of ZDHC in the next year or immediate future. And some areas where they should be very operators should focus are constituents of wastewater, water quality monitoring, the treatment technologies that is needed for organic and inorganic removal, and water recycling. Dr. Woodling and myself, we are GDHC approved specialist trainers. A number of our colleagues are also trainers, GDHC approved generalist trainers. And we have already provided training to many textile facility operators. So with that, we conclude our presentation. We'll take questions now.
Okay, thank you, Dr. Woodling and Dr. Patanayak for this interesting insights. We will now take questions from the audience. So just a reminder, you can send in your questions through the Q&A function directly to the host and we'll address that. So we have some questions that has already been sent to us. Let's start with that. The very first one that we have is, how does ZDHC Wastewater Guideline compare with national standards?
I think I'll take that one. Typically, the ZDHC guidelines and the national standards can be actually quite different. One of the primary functions you have to do for ZDHC is actually meet the national standard, but then there are additional requirements on top of that, which are frequently far more stringent than what you see in the local governments.
Okay, thank you. The next one that we have is, how frequently would you actually recommend sampling to textile facilities during your audit, and why?
We typically see that facilities, they measure the parameters that are important for them to meet regulatory requirement. But a lot of the times that is not sufficient to understand what is happening to their wastewater treatment plant. So, and that's why we select parameters, we select a number of days to make sure that there is sufficient understanding of the wastewater treatment plant performance or health.
Okay. The next one we have is, antimony discharge limits are stringent in ZDHC Wastewater Guidelines. Do you have any comments on BAT for antimony removal?
Typically, the best available technology for antimony removal is associated with a iron co-precipitation, it's called, and you precipitate the antimony along with the iron. Many of the manufacturers of the polyester thread, which is where the antimony is coming from in the first place, it's a catalyst for polyester formation. Many of the manufacturers are looking at ways to produce polyester without the utilization of antimony, and ultimately that'll be the answer to removing antimony from the waste stream in the first place. But if it's present, you typically treat it, the most cost-effective way is to treat it with iron co-precipitation.
Okay, thank you. I hope that answers the question. The next one that we have here is, in one of the slides you mentioned that headwind modeling has been used for greenfield wastewater treatment plant feasibility studies. Could you talk more about the approach briefly?
Yeah, that's a good question. What we typically do is we have an understanding of so we have been to many facilities, and we have an understanding of what kind of processes work for a specific set of wastewater. So then we know what would be the process schematic, and then the typical retention times, the aeration requirements, clarifier sizing, or if it is an MBR system, then it is membrane-related information, the requirement for sludge recycling. So all this information, we set up the plant or a hypothetical plant in Pequin, and we put all this information. We can use one set of data, or we can do a range of data, and then we use default modeling parameters for both kinetic and stoichiometry, and then we run simulations, number of simulations. It can be steady state or more dynamic, and then see how the system is performing. And one important criteria here is we should have wastewater characteristics information, that is flow, COD, BOD, and all these kind of parameters. And that is how we evaluate a greenfield wastewater treatment plant.
Okay, thank you for answering the question. The last one that we have here is, what is the biggest challenge for implementing water recycling in textile facilities?
Oh, I think we both can take that one. Yeah. The greatest challenge is keeping the systems that you have operating at a high performance level so that the recycling system gets the quality of water it needs in order to function well. A secondary challenge is that in the recycling systems, you typically are concentrating the residue that's left in the wastewater. You'll concentrate it up. Now, that requires a secondary treatment system so that you still meet ZDHC discharge requirements, because you have with the concentrate, you will still have to achieve those discharge requirements. So if you look at a typical RO system, reverse osmosis system, you'll see that it's recovering somewhere between 50 and 75% of the water that it's fed to it. So that means that you're potentially doubling to tripling the concentration of the contaminants that are residue in your water. You could be achieving ZDHC progressive requirements, or all the way up to aspirational, in your wastewater treatment plant, but when you put in a recycling system, it could take you out of compliance because you've now concentrated everything else up in order to get clean water to use back in the process. However, there are good ways to go and treat that concentrate so that it does, in fact, meet ZDHC requirements for discharge and maintain the local regulations too.
Okay, thank you. So thank you, Dr. Woodling and Dr. Patanayak, for taking this question. So for now, we don't actually have any questions. So if there are any further questions that comes through after the webinar, please just drop an email, and then we will forward to the expert for them to revert. So we hope that you found this session interesting and relevant. We have several webinars in the pipeline, hence we encourage you to sign up for the Consumer Products and Retail Essentials newsletter at www.tsud.com/CPS to get the latest news, regulatory updates, and more. If you have any questions regarding the webinar topic or what we do feel free to email us at cps@tsud.com. Thank you for your time and have a good rest of the day ahead.